Now we're going to take our area model kind of to a whole new level, and we're going to do some different summations. We're going to do what we call like a left-hand sum and a right-hand sum. But what we're going to sum is rectangles. So we're going to create a bunch of rectangles based on what's given in the problem, and we're going to use the areas of those rectangles to approximate the total area under the curve, or whatever line or function that we're looking at, or the total area that kind of goes slightly above that. So you're going to see as we do the two different approximations, one's going to be slightly under the curve, one's going to be slightly over the curve. So one's kind of an over approximation, one's kind of an under approximation that we're going to do to kind of find an area of a region. Now example 8, I'm not going to get into a whole bunch of depth about how we actually find the right and left hand endpoints. We're going to do that in the next video. But this is just kind of a brief overview for you to kind of get the concept of what we're talking about with right endpoints and left endpoints. So let's look at the example 8 though real quick. It says use right endpoint and left endpoint methods to approximate the area of the region lying between the graph of f of x equals minus x squared plus 5. You see that curve right here. That's a downward facing parabola. The x-axis, so we stop there, and we want to go between when x is 0 and x is 2. So on the graph here that I've drawn, you can kind of see it has 10/5. Okay, that's going to make sense to you in a little bit, but that, 10 divided by 5 is 2. So we've chunked this up. All right, and in the example it says use 5 rectangles to approximate this. All right, so if you can look at the area under the curve here, there's 1, 2, 3, 4, 5 different rectangles. And we use rectangles to help approximate because we know the area, or I'm sorry, the formula for a rectangle, right? It's length times width, or width times height, or however you kind of want to approach it in that problem. You've been doing that for years. But now we want to use a summation to do that so it goes quicker for us. So what we're really looking at is if we look at the right-hand endpoints method. I don't think you can see my cursor on here, but if we look under the curve, if you notice, if you look at each individual rectangle, notice that the upper right-hand corner is touching the curve. So that's really what we mean when we mean the right-hand endpoints. And we're going to use the right-hand endpoints to calculate that's the height of each rectangle. Okay, we can see the width, and I'm going to teach you how to get to the width here on the next video as well. We can see the width. The width is going to be even each time based on the number of rectangles that we're going to use. But it's really understanding the right hand and the left hand endpoints. So looking at this first graph right here, if you look at the upper right hand corner of each rectangle, each one of those points is specifically touching the curve. So that's the right hand method. If we notice in this scenario, the total area under the curve is going to be an under approximation, because you notice on some of these rectangles there's a space between the top of the rectangle and the curve. That's area that we're not counting in this scenario. So it's going to give us an under approximation of what the exact area is. Okay? So don't fret right now if you don't understand where the 2/5 is coming from. We're going to do that in the next video. Right now I just want to go through this so that you can understand, alright, this is what the area is on the right hand side versus the area on the right hand side. Okay, we're going to create a summation. When we look at the summations here, well, 1 to 5 represents the number of rectangles that we're doing. Okay, then we have to represent the height of each function. That's what we're going to plug into f of x. F of x in this case, that's our negative x squared minus, negative x squared plus 5 here. Alright, that's this piece right here. That's the f of x we're going to plug into. And we're going to plug in increments of 2/5 I. That way, what is that doing? That's telling us that we're substituting in all the right hand endpoints, and that's going to give us the height of that specific rectangle at I. So when I is 1, our first rectangle, okay, we'll only be plugging in 2/5. When I is 2, we'll be plugging in 4/5. So that's what I have written along here, where it says evaluate f of x at each one of these right endpoints. Okay, so when we substitute in Alright, each one of those values is going to give us a y value. So that's our height, and then we have to find the width of each triangle. In this case is 2/5. Alright, a brief overview of where this 2/5 comes from. Alright, if we look at the graph that we're doing here, we're going from 0 to 2 in the x-axis. Okay, so that's the distance we're covering in x. And then we want 5 rectangles. Okay, so for us, we're going to take 2, our distance in x, and divide by the number of rectangles we're taking, 5. So that's where the width of each one of these comes into play. Alright, and like I said in the next video, we're going to get into more depth about how we develop the right-hand endpoint and the left-hand endpoint. There's a specific little formula we can use where we actually just substitute in and it kicks out right for us. Okay, but that's where the 2/5 comes in from. Alright, our x length that we're covering divided by how many rectangles. Okay, and then I'll go through this in the next example. This is literally just doing our sums then. And for you guys, I taught you how to put it in your calculator. Just put this in your calculator and let it do the work for you. If you're not getting the right answer in your calculator, make sure that you're keeping track of parentheses. Order of operations, you really need to set that up for your calculator in there. Alright, before we finish this video up, let's go over the left endpoints. So this is part B. So if you look at the difference now, this is a graph, the same curve, minus x squared plus 5, but now we're using the left-hand endpoints. Notice now if you look at each rectangle that's drawn on that curve, the very upper left-hand corner of each rectangle is touching the curve. So that's what it means when we're using the left-hand endpoints. So also with this is our over approximation of the area. Notice that the rectangles cover the area under the curve and then a little bit of the area over the curve. So that's our over approximation in this case. So we have to develop, okay, the width is going to be the same of each one of these rectangles. It's still going to be 2 divided by 5, alright, because 2 is how far we're going in the x-axis, 5 is how many rectangles we want to use to solve this. Now, like I said, in the next video I'm going to get into depth about how you actually calculate each one of the left-hand points. Alright, so right now, I wrote in these notes we choose 2/5 times I minus 1. I'm going to show you how we're going to get there next video. But this part of the equation right here is really what's developing each one of these points. Alright, and remember the left-hand points, those are the heights of the rectangle, and we're going to multiply that by the width down here in a sum. So this 2/5 times I minus 1, that represents the height of each triangle that we're substituting in, and we're all going to take the height of each rectangle, the height of each rectangle multiplied by the height of each, by the width of each rectangle. So height of rectangle times width of rectangle. Sorry if I said triangle before, so anytime I said triangle in this video, I really meant rectangle. I don't want to go back and re-record this, but so we're taking a look. This is the height of each rectangle using the left-hand points. This is the width of each rectangle. Alright, so height times width gives us the area. So you'll take this piece and you're going to directly substitute in where all of the left-hand endpoints are in for x into the function. That's where the plus 5 is, because our function is minus x squared plus 5. Notice wherever there's an x, we're going to replace it with this 2i minus 2 over 5. And don't worry about this, we're going to learn this in the next video how to get there. I just kind of want to give you a brief overview of what we're doing. Once again, the sum is I equals 1 to 5 because we're doing 5 rectangles. Alright, we're going to substitute in the value and we're going to find the area of each one of those rectangles. Once again, substitute this into your calculator, keeping track of parentheses and organization of order of operations. If you don't put a parentheses in the right spot, your calculator may give you the wrong sum. So I would practice with example 8 using your calculator and putting them in, making sure that you're getting the values that I have written here. Those are the correct values for those sums. So really kind of get a handle on making sure that you can substitute into the sums there. And what I really wanted you to get out of this is hey, let's look at this rectangle approximation. This is a right endpoint method, and we are approximating the area under the curve, and this is an under approximation. And then this is the left hand endpoint method. We're using the left hand side of the rectangles to calculate the height of the rectangle. Okay, and this is an over approximation. So eventually we're going to learn a method that gives us the exact approximation of the area under the curve, but this is one methodology where you can say, alright, the actual solution to this, if we come down and look, is the area lies between the right hand and left hand point. So if you notice this 6.48 that I have right here and this 8.08, the 6.48, that was the total area of the right hand endpoints, and the 8.08 was the total area of the left hand endpoints. So we know that the area of the region under the curve is somewhere between 6.48 and 8.08. This hopefully will all make sense to you in the next video that I'm going to make, where we explain exactly how to get the endpoints and clear all this up. But understanding that we're using rectangles to approximate area and adding up all the areas of the individual rectangles to get as close as we can to the true area under the curve.